Our next speaker is Mr. Thomas Wiedenhoefer from PTV Germany. He will be presenting the topic digitalization in the field of National Metrology Institute. Mr. Thomas Wiedenhoefer studied production engineering at the University of Erlangen-Nuremberg, Germany. He's a specialist on manufacturing metrology, quality and project management. Since 2015, Mr. Wiedenhoefer is member of the National Metrology Institute of Germany, the Physikalisch-Technische Bundesanstalt in Braunschweig. Here, he supported a strategic project at the executive level of PTV Division 1, Mechanics and Acoustics. This included, for example, projects on the dissemination of the unit kilogram or the organization of the project for setting up a competence center wind energy. Today, he is, among others, member of the presidential staff of PTV, supporting the European research project of PTV. Prior to his work at PTV, Mr. Wiedenhoefer gained 7 years of experience in industry in a leading position as a director for research and development cooperations at a renowned manufacturer for multi-sensor coordinate measuring machines. Please remember to send your questions to webinar@send.es. Mr. Thomas Wiedenhoefer, you have the floor. Thank you.
Thank you very much, and congratulations for your good German. Okay, hopefully you see my presentation. And I would start with a wonderful good evening from Braunschweig, Germany. It's getting a bit dark now, but in digitalization we have 24 hours, 7 days a week to work, therefore no problem at all. First point for me was digitalization in the field of National Metrology Institutes. What does this mean? On the one hand, the NMIs transform their own infrastructure. On the other hand, they carry out joint research regarding digitalization with other NMIs. And maybe on a third hand, they exchange data with one another. In the field of data exchange, there's a whole variety of practices, and it is sometimes very individual. Therefore, I will focus only on the first 2 points. The transformation of our own structures and the research projects with others. Here, a slide I found in the internet and everything we all experience every day. The use of mobile devices and digital tools are increasing, and it feels quite natural. We are becoming somehow digital natives. Therefore, in our daily work, it is not that included than in our private world. The future will completely change, and we all will have digital tools available in metrology, and they are like using a mobile phone today. No specific problem with this. Our processes at the moment are maybe not future-proof and not fully transformed. But how can we change this in a global sense? Here the NMIs have to take over a leading role. They are on the topmost level of metrological hierarchy and are internationally well connected and have the metrological expertise needed for such a transformation process. Some general challenges, we've already heard some challenges. We will have new opportunities as being created anywhere. The Internet of Things and Industry 4.0, we all know about this. We've heard a great presentation prior to this. Major challenge for me is the sophisticated system of quality infrastructure we have today, consisting of metrology, accreditation, conformity assessment, norm standards, market surveillance. All these sophisticated systems have to transfer to a digital world. This is not an easy task to do. And end of the day, the NMIs have to continue and guarantee the safety of and the confidence in the measured values. That's a core thing to be done, that we trust in our measuring and our measured values. What is digitalization and the transformation at PDB? And maybe not only at PDB. In discussions of the last years, we found that the ideas are similar in other NMIs because we have somehow similar tasks, not maybe all, but most of them. We have 4 key areas identified: metrology for simulation and virtual measurement systems. We had the virtual world in the presentation before. This is covered by this, covering simulation of complex measurement systems, virtual measurement processes, and methods and standards for automated production. As my roots are in coordinate measuring metrology, I'm very used to use virtual machines for calculating of measurement uncertainty. We did this 20 years ago with a system available in the market. It was only available, for example, for single point measurement uncertainty calculation, not for scanning. This took another 15 years to get this ready as well. But simulation is not a new task, but we go maybe a step further nowadays with so-called digital twins. We have a second task with metrology of communication systems in the digitization. Here, complex high-frequency measurements, where I have a huge amount in short time to be conveyed. And for example, if I want to convey with each measurement timestamps, then this may be too much to be conveyed through the channels I have available. Digital communication systems, complex antenna systems, that's what we do see here. Then a third task, metrology in the analysis of high-dimensional data. We need scalable methods for high-dimensional data analysis, metrological evaluation, and for machine learning methods. And the fourth field is digital transformation of metrological services, digital enabling of quality infrastructure. We've heard about the Metrology Cloud before, and this is a project started here in PDB and will be transferred to a European Metrology Cloud, and transfer of units is covered here as well. Objectives we have is one core objective, clearly for NMIs, uniformity in metrology. We need standardized machine interpretable information throughout the entire data life cycle. And on top most of this, we have the system of units, the SI. We need something similar in the digital world. We need digital SI. I will have a slide on this later on. In this category, the digital calibration certificates already mentioned and urgently needed in industry are covered. We have set up a metrology for virtual measuring instruments competence center within PDB, where we are developing virtual measuring devices and digital twins. And last but not least, a third example here, machine learning and artificial intelligence. Here, one example based on machine learning, helping to read mammography images in a better way. The second core objective is sustainable usability of research data, means research data management, data-based research and development, guaranteeing quality and reproducibility, and that I can understand what is the context where the measurement is coming from. I need the FAIR principles to be involved. We are here in technical committee of Euromed research data management. We are in national developments also, and as I'm in an MPL project, we were forced somehow to implement a research data management plan and figuring out during process lifetime how good it is to have one if it comes to data exchange with partners all over the world. A third objective is the efficient use of digital technologies. That's more some internal things that we change our system, how we communicate and store data within PDB. It's called e-file system, and we have a platform interface to our customer where they can ask for digital services, for metrological services. It is transferred to the working group carrying out, and no paper needed any longer. And a fourth objective is, we shall not forget this, the active participation of all employees in digitalization. We shall be aware that no one can feel left behind. We have to introduce it maybe step by step. We need to figure out who are the digital pioneers. We tried this, for example, with a project for metrology for the city of the future, where we invited digital pioneers from industry, asking what is the need in 20, 30 years. And we need to prepare seminars, training courses, learning opportunities. We have to teach what does it mean to be transferred to a digital process in future. And maybe one big thing and most of interest to you as an industry, holistic concepts for measuring instruments and data. We need digital interfaces and interoperability across various fields of application. Metrology Cloud already mentioned, a decentralized platform for digitalization processes in legal metrology so far. We have the digital calibration certificates. What does this mean? I will explain in a minute. And we have funded joint research projects with regard to digitalization. Here, one project, SmartCom, and we have a project, Metrology for the Factory of the Future. Both projects really working in the field of digitalization and joining forces. For example, we share a stakeholder advisory board, advising both projects what is needed by the stakeholders, by industry. And a third project here, Can We Make 2, is a German project where the digital calibration certificate is brought to life. I would give a short success story in digitalization. Our MPA project, SmartCom, started 2017, because this may be of interest to you. You've already heard or know about Euromet, the European Association of National Metrology Institutes. They do coordinate the cooperation of the NMIs in Europe, and they have two main tools so far. It is the EMRP program and the MPA project program, which is still ongoing, with by far more than 100 joint research projects so far. We've heard about the different calls and what they are focusing in. Therefore, I can skip this slide and just mention one point which was a bit problematic in the past, that there was no specific funding for digitalization projects, because we then have to compete against very interesting projects from nanometrology, quantum cryptography, and things like that. Therefore, it is hard to stand in an industrial call with a digitalization project. You always have to somehow be linked to industry. It's not, in the end, a bad thing, because then you are aware of what is needed from industry. One slide I found that interesting that I would like to present it to you, even as it's from February 2020, an overview of Euromet's research program and what they achieved. Total investment to this point, February last year, over 400 million euro, over 800 presentations, more than 30,000 people being there, over 2,500 publications in peer-reviewed papers, over 5,000 presentations. These impressive figures show how important it is to have such a program, because it brings us a huge leap forward. The project, SmartCom, was dealing with the digital SI, digital representation of the SI, of the system of units, the fundamentals for digital calibration certificates. It's not only the technical thing, we also have legal things like who is liable at the end, or where can I store it, or what is about third part of the project, how do I validate a DCC? Is it any longer valid or not? The project was with European NMIs, and we also involved 3 NMIs from Asia, with Chris from South Korea, with ITRI from Taiwan, and from China, Zenim. And we had really strong industrial partners in the real world, real life competitors joining forces here to bring forward the topic of digital calibration certificate. You see companies like Zeiss, Hexagon, Mitutoyo, and in weighing, for example, Sartorius and Hexagon. And they are all interested in bringing forward this essential digitalization topic. A very, very, very simple and easy to understand model for our representation of an SI unit in a digital world. We do not program in a specific language. We say we need a value, we need a unit. That's clear to all of us. But then I might have the need for a label and maybe a timestamp. That's some optional information. And the vision behind all of this is no measurement without a result, without a unit. And best without no measurement result without SI unit. The digital calibration certificate, we brought together all standards and norms. Most of crucial standard is 17025. We designed core regulated administrative data, for example, name of laboratory, a shell where we have put in the calibration results in this digital SI, a third shell where you can put in comments, free, you can put in everything you like. And at the start, we were of the opinion that we need a fourth ring with, for example, human-readable PDF that we easily can understand what the machines are exchanging here. But in future, it's no need for having this fourth thing. Combining all this information leads to the digital calibration certificate. We are prepared XML examples. You can program it in JSON, whatever you like. You have only to use the structure and the keywords that we can understand one another. Very interesting for you maybe that this digitalization project has a huge success, as the idea has become taken up by an international task group, Digital SI, under the MITA convention of CIPM. This international expert group will give recommendations for a uniform digital data exchange. The aim could be something like a machine-readable SI brochure. And today and tomorrow, stakeholder workshop takes place at the BIPM in Paris, talking about a digital SI. Main reasons for the success in our project: we've been part of the Euromed family. That's the major reason for me. We've been funded. It was an enormous project. We had cooperation with other JRPs. We had access and used guidelines and publications. We also provided publications to the Euromed community. We have the European metrology networks. We have the technical committees for us in interdisciplinary metrology. Two committees, work groups here, one dealing with digital calibration certificates, and the second one with research data management. Then we had the chance to invite a guest scientist over the funding as a researcher mobility grant. He is learning at our side what does it mean to set up a DSCC, and we learned from him some programming technology. It was a win-win situation and a great thing to have within our project. Training material, we visited trainings, we gave trainings. That's a great thing to have such funding as we have in MPIR under Euromed and Horizon 2020. As you see here, only a glimpse of the distribution of the members of the DCC working group in the TCIM 1448. You see, they are stretched all over Europe. It's a topic we are all interested in, and we all have to be aware and have to be part of. Some further groups and developments. We have a new working group since last year in Euromed, Digital Transformation in Metrology. I will also tell you that there's a European Open Science Cloud, very trusted digital platform for the scientific community to offer the possibility to access and to reuse all publicly funded research data in Europe. Very interesting and great thing. And also since last year under IMECO, the non-government federation of 24 member organizations in metrology, digitalization committee dealing with the transformation of measurement processes and the quality infrastructure. You see, on many fields and in many organizations, we start with an effort to bring forward digitalization, and we all have to be part and can be part of it. To summarize and give a short outlook, digitalization affects all areas of economy and society. The NMIs, as for example, the PDB aims for developing the foundation for an efficient digital transformation of industry and society. Together with you, we have the need to be informed what is needed, then we can act. Ensure the reliability of innovative and smart technologies. NMIs are aware of changes and do prepare solutions and do have joint projects where we invite industry to be part of. Metrology organizations worldwide do have digitalization on their agenda. We need to have the digitalization on our agenda and develop it further. Parts of the presentation are based on results from our MPA project SmartCon. You have seen it. Here are 3 links for our local information at PDB to find the digitalization projects carried out at PDB. You have the link to the Euromed page or IMECO. And I also included here a short survey on digital calibration certificates. It's the point I've told you, we need the input from industry, from the stakeholders. What is needed? What are you using today? Are you aware of? Do we need to share more information? That's not a big thing. If you find the time, please take part. That's what I have to present today. There are many, many things going on, and we as NMIs can support industry in many fields, but we need your input, support, and collaboration. And it's never a PDB or something to do. It's a thing we do for the whole world and for our future. And thank you very much for your attention.
Thank you very much for your presentation, Mr. Thomas Wiedenhoefer. Our next speaker is Dr. Niels Medina from the Centro Español de Metrología. Dr. Nieves Medina has a Master of Science degree in Physical Science from the Universidad de Salamanca and a PhD degree in Metrology from the Mechanical Engineering School at the Universidad Politécnica de Madrid. She has been working in metrology since 2000, and she is currently head of Mass and Mechanical Quantities at SEM. She is a member of several committees and working groups in different metrological organizations, such as Euromed, the Consultative Committee of Mass and Related Quantities of CIPM, OIML, and IMECO. Her metrological background includes metrology for mass, density, force, torque, vibrations, and pressure, as well as mathematics, statistics, and quality applied to metrology. She has authored numerous work in these fields. She will be presenting the topic, the example of the Centro Español de Metrología, Spanish National Metrology Institute, current practical examples. Please remember to send your questions to webinar@sem.es. Dr. Medina, you have the floor.
Thank you, David, for your nice presentation. I hope everybody can hear me now. Yeah? Okay, I will try to share my screen. Well, I hope you can all see it right now. Good evening to everybody. It's an honor and a pleasure to be part of this webinar. I have the opportunity to give a very brief taste of what we are doing at the Spanish Metrology Center, Centro Español de Metrología, in the issue related to digitalization. The aim of the objective of CEM as an institution in this revolution of digitalization is not only to provide a digitalized industry, that is the topic of this webinar, but in general to provide new services and also improve the existing services that we are providing. My presentation has 3 parts. The first part is the presentation of the digitalization plan that we are performing at the Spanish Metrology Center. And the second and the third part will be 2 practical examples of how this digitalization plan is being implemented. The digitalization plan is a very important plan of the a very important part, of the strategic plan that we are having at CEM. The strategic plan, President Blanco has spoken quite a lot about, a little bit about it, is the layout that CEM has as an institution to establish its objectives. So the digitalization plan is a very important plan. It will be developed from this year until 2024, and it will have a budget of 7 million euros. The digitalization plan has been established following these steps. The first thing has been excuse me. The first thing has been to establish an initial diagnosis in order to know what was the situation of the Spanish Metrology Center related to the digitalization, and also to know the needs of the Spanish society related to that. From this initial diagnosis, we have developed a general strategy, and then from the general strategy, we have developed the objectives. From the objectives, we have developed the action lines, and from the action lines, we have developed the activities. The results of the initial diagnosis have been established as, on the other hand, we have had weaknesses and strengths, and we also have had menaces and opportunities. Among the weaknesses that we have identified, the most important ones have been the lack of a digitalization transformation strategy that we had at the beginning of the implementation of the strategic plan, the existence of quite many systems that were obsolete or with a low level of automation, and also the fact that we have few staff with ICT, robotics, and digital skills and qualifications. Among the strengths, we have identified a very important thing, that we have a strong support from our ministry, from the management point of view and also from the technological point of view. And we also had the possibility to participate in many external forums. For instance, at the European level, we can participate at MP projects. We can participate also in European metrology networks and other European Euramet projects. Among the MP projects, for instance, I can just remind that we participate in the project Metrology Cloud that Dr. Thomas from PTB has already spoken about. And we also participate in the MP project called Factory of the Future. Just a couple of examples, but our intention is to participate more and more in MP projects related to the digitalization world. We also participate in other external forums, such as WELMET, that is related to legal metrology, the OEML, also related to legal metrology, but in an international background, framework, I would say. We also intend to participate in IMECO TC6, that is a technical committee specialized in digitalization, that has already been mentioned. And we also can participate in forums related to accreditation or standardization. Among the menaces that we have identified, the main ones have been the high speed of digital transformation that we are facing nowadays, the security threats that we face whenever we intend to have a digitalization transformation, the technological dependencies that we could have from external entities, and the most important one is the literal awareness of the need of metrology. That is something that I think many of us are facing all the time, and it is something really worrying. But we are always fighting for that. And among the opportunities, we identified that we can lead the digital transformation of the national metrology in Spain. We had also the opportunity to provide new services. We can also increase our efficiency and also increase the transparency of our work. And we can also use new digital tools for a better dissemination of our activities. So with this initial diagnosis, we established the general strategy, and we had two strategic axes. One is ensuring the viability of SENS digital transformation, and the other one is strengthening SENS position through the provision of customer-oriented digital services. From the first one, we identified two objectives. The first one is focused on human resources and infrastructure for digitalization, which deals with system renovation, cybersecurity, and training. The second objective is focused on automatization and connectivity, and deals with equipment and facilities. The third objective is related to the paperless office, and it deals with digital services, home working, and efficiency increase. The fourth objective is focused on promotion of digital platforms, and it deals with legal metrology, designated institute, and European participation. And the final objective was focused on digital and online services, and it deals with digital certificates, online audits, calibrations and verification, and the application of artificial intelligence tools. So that was a brief taste of the digitalization plan that we are implementing at CM. And now I'm going to start with the practical examples. The first practical example is the implementation of artificial intelligence tools in metrology, in the case of the sensor characterization in use. So what do we have up to now? Up to now, in a sensor characterization, we have the calibration, and we have to consider other influences that can have an effect for the sensor response. There are many. Here in the slide, we can just some examples. For instance, we can have environmental conditions such as temperature and humidity. We can have dynamic effects. For instance, that is the effect that the quantity under measurement change in time effect in the sensor response. We can have also mechanical effects such as creep, hysteresis, the mounting effects of the sensor in the system, electrical effects such as the supply voltage or the signal filtering of the output of the sensor. And we can have others such as grid adjustment. There are many others. So up to now, we had a classical approach. What do we have in this classical approach? With the user had to calibrate his sensor, of course, that's the most essential thing. And then he had to study each influence separately. most of the times, the user didn't have any information apart from the information that came from the manufacturer that was not really detailed. So in practice, most influences could not be corrected. And in general, we had a high uncertainty in the use of the sensor. But with the new approach that we intend to develop, the idea is to calibrate the sensor at very different conditions. For instance, if we have a sensor that has a temperature influence, to calibrate it for different temperatures, and then use machine learning techniques in order to provide a model of the sensor response in use. At the moment, we are doing it for the case of for transducer characterization. We're doing it under we're doing it for a project, an MP project that is under development at the moment, that is called Contraforce. And the aim of this project is the provision of comprehensive traceable force calibration methods for force measurement applications in material and mechanical testing. So we start, what we have in the beginning to start is we have a force sensor, and the force we are applying suffers sinusoidal or sawtooth excitations. We consider that the sensor response is arbitrary, and we consider that it has as influence effects things such as creep, hysteresis, temperature, and drift. So with this, what we have started is we are using neural networks. In fact, we are using a neural network, special neural network that is called long short-term memory neural network, and this is being implemented in a platform called TensorFlow. Maybe you know it if you are a little bit familiar with issues related to neural networks and machine learning. And this is a platform that runs in Python. So what we are doing is to use as inputs certain values for force, time, and temperature and transducer output, and then to train our network and to produce a model that will give the transducer output for a whole range of force, time, and temperature. This is rather challenging, and we are working on that, and for the moment we are having quite nice results. That was our first example, and now I go on with the second example that deals with the online verification of Doppler speed meters. The Doppler speed meters are the common traffic radars that are used to control, sorry, not to control, to measure the speed of the vehicles in motion in our roads. So these meters, these speed meters, are under legal legislation here in Spain, and according to this legislation, they have to be verified periodically. So, in order to understand what we are doing, I have to explain a little bit about what is the way this sensor works. The working principle is the well-known effect called Doppler effect, and what we have is that the radar has an antenna, and that antenna emits an electromagnetic wave that goes to the vehicle under motion, and it returns from the vehicle under motion to the antenna with a frequency shift that is given by this formula that we can see in the slide. And this frequency shift, delta F, as you can see, is proportional to the velocity of the vehicle under motion, that is called V. In general, the performance of these speed meters is rather complex, and there are many influences there. But one of the most important ones, and the most important source of error, is the signal processing that is used to obtain this velocity for the reflected signal from the vehicle. So the idea is to verify the signal processing online. And that is what we are doing at CM. So what are we doing at CM? At CM, we consider the signal that arrives at the antenna from the vehicle under motion. And what we do is, on the one hand, the signal is signally processed by the speed meter, and the speed meter gets the speed of the speed meter. And there is a server at CEM that receives this value, this speed. On the other hand, the system that we have at CEM gets the signal that is received by the antenna that is coming from the vehicle under motion. It gets this signal, and the signal is analyzed directly by the server at CM, and the server obtains the speed directly, that is the true speed of the vehicle under motion, so that the same server can obtain the error of this measurement, as the difference between the speed that has been measured by the speed meter minus the real velocity that has been determined by the same server. The system is called Rabiot, and it's very, very challenging because everything is performed in real time by means of 4G communication. So this is something very new, and at CM we are really proud about it. So that has been all from my side. Thank you very much for your attention, and I hope you have had a clear view of a clear taste of what we are doing at CM for adapting ourselves to this digital revolution. Thank you very much.
Okay, thank you very much for your presentation, Dr. Medina. Mr. Carlos Juste will be presenting next. His presentation is named "The Need of a Cloud Infrastructure for a Digital Transformation of Metrology in Spain." Mr. Carlos Juste is a specialist and teacher of digital marketing, data-driven, and growth hacking, marketing automation. He has a master in data science. He's also a digital transformation consultant and manager of technological training. Please remember to send your questions to webinar@sem.es. Mr. Carlos Juste, you have the floor. Thank you.
Thank you, David, and kudos for your work today. Okay, I'm gonna share my screen. Okay, thank you all very much for attending this webinar today. Allow me to express the great honor that is for me to be here this afternoon as a speaker at this great event. Also, allow me to explain how I got here and where I came from. As a consultant, I'm fully dedicated to advising companies in digital transformation, and more specifically in digital marketing. That's what I'm talking about today, marketing, most of it. I have worked for all types of companies, large, small, public, private, startups. Among my clients, the CM is one of my dearest. And in the last years, I have been developing its electronic magazine, Medida.es, if you want to visit. During our work sessions and subsequent breakfast at the CM bar with my dear colleague Jose Angel Robles, an interesting debate arose about the future of metrology and the vital need to develop an infrastructure in the cloud was mentioned on this conversation, something like Amazon Web Services or Azure or many others, but dedicated only to metrology from all points of view. The intention of this presentation is precisely to transfer that conversation to a totally informative environment, always trying not to bore you and that nobody falls asleep. Now we've got here, please let's take a look back and let me put some perspective. Android operative system, the one we use in most of our mobile phones, was born in 2008, Facebook in 2004. Google is just over 2 decades old. The Apple Watch was born in 2015 with a few features. Today it is capable of detecting heart disease or even COVID. Or think about Zoom. Zoom was non-existent 2 years ago. Now Zoom is everywhere. That only in a few years. I could go on like this for days, but you have already lived this. You know what I'm talking about because you have witnessed it. Given this, what can we see in the future that await us? Let me talk a little bit about it. I have no glass ball and I'm not a viewer, but if we take into consideration what the experts are telling us, to make a long short, we can expect a lot of devices of all sizes connected to each other, measuring all kinds of things and generating all kinds of services. Some will be connected directly to people, even inside of our bodies. Others to machines that will talk to each other. Some will be visible, some will not. Some will go, again, inside of body, and others within our body. More specifically, we can talk about Industry 4.0. Other speakers today have talked about it. Also known as the new industrial revolution. According to Wikipedia, the fourth industrial revolution, or Industry 4.0, is the ongoing automation of traditional manufacturing and industrial practices using modern smart technology, large-scale machine-to-machine communication, the so-called M2M, and the Internet of Things are integrated for increased automation, improved communication, and self-monitoring, and production of smart machines that can analyze and diagnose issues without the need for human intervention. The phrase fourth industrial revolution was first introduced by a team of scientists developing a high-tech strategy for the German government. We're going to talk a lot about our German friends today. Klaus Schwab, executive chairman of the World Economic Forum, introduced the phrase to a wider audience in 2015 article published by Foreign Affairs. It was called Mastering the Fourth Industrial Revolution. It was the 2016 theme of the World Economic Forum annual meeting in Davos, Switzerland. Our German friends are leading all the efforts towards a futuristic industry, and please let me warn you, we're going to talk about Germany a lot during this speech. They know what they're doing. And what do German think about this? They have designed they have so as the design principles and goals of this industry 4.0. The following design principles identified in Hawaii International Conference on System Science on a research paper by Mario Hermann, Tobias Pentek, and Boris Odo, three of them German citizens, helped to define the technology and approaches that make up Industry 4.0. First one, interconnection, the ability of machines, devices, sensors, and people to connect and communicate with each other via the Internet of Things or the Internet of People. This is a new concept. You will hear a lot in the near future, the Internet of People. Then, second principle, information transparency. The transparency afforded by Industry 4.0 technology provides operators with comprehensive information to make decisions, informed decisions. Interconnectivity allows operators to collect immense amounts of data. That's what's called big data, and information from all points in the manufacturing process. Identified key areas that can benefit from improvement to increase functionality. Then, technical assistance, the technological facility of systems to assist humans in decision making and problem solving, and the ability to help humans with difficult or unsafe tasks. Decentralized decision, that's the fourth principle and goal. The ability of cyber-physical systems to make decisions on their own and to perform their task as autonomously as possible. Talking about robots. Only in the case of exceptions, interference, or conflicting goals are tasks delegated to a higher level. And which are the components of this industrial revolution? Now we're talking about things that we already know or we already have tried. The fourth industrial revolution consists of many components. When looking closely into our society and current digital trends, to understand how extensive these components are, here are some contributing digital technologies as examples. Mobile devices, we all have one. Internet of Things platforms, location detection technologies, electronic identification, advanced human-machine interfaces, authentication and fraud detection, smart sensors, big analytics and advanced processes, multi-level customer interaction and customer profiling. This is very interesting in terms of marketing. Augmented reality and wearables. We've seen a few examples so far, like the Google Glasses, but there's a lot of things to come in this field. On-demand availability of computer system resources, and then data visualization and triggered live training. This is a good example of live training, this webinar. And well, in terms of legal metrology, if you see, all these components are a big deal. Metrology will be a key actor, a key actor in this scene. Then, if you want, these techniques can be summarized into four major components, defining the term Industry 4.0 or the smart factory. First, the cyber-physical systems. Second, Internet of Things. Third, on-demand availability of computer system resources. And fourth, cognitive computing, machine learning, natural language processing, and speech recognition. We've seen a few examples of this so far in the previous presentations. Who is going to affect this fourth industrial revolution? Everyone and everything. This is going to be a major change in our civilization. We're heading a lot of changes, and in essence, the fourth industrial revolution is the trend towards automation and data exchange in manufacturing technologies and processes, which include cyber-physical systems, Internet of Things, industrial Internet of Things, cloud computing, cognitive computing, and artificial intelligence. And let me now talk about the primary drivers for all these changes. First one, digitalization and integration of vertical and horizontal value chains. Industry 4.0 integrates processes vertically across the entire organization, company, business, uh, administration, public administrations, including processes in product development, manufacturing, structuring, and service. Horizontally, Industry 4.0 includes internal operations from suppliers to customers, as well as all the key value chain partners. The colleague from the vast country has talked a little bit about this. It was very interesting. Digitalization of product and services, that's the second one. Integrating new methods of data collection and analysis, such as through the expansion of existing products or creation of new digitalized products. That helps companies to generate data on product use in order to refine products. This is the new marketing. And then fourth one, digital business models and customer access. There is a mistake in this point. We're talking about digital business models and customer access. Customer satisfaction is a perpetual multi-stage process that requires modification in real time to adapt to the changing needs of consumers. In the modern marketing, customer is the center of all what we do. If we take a good look to all of this, we all can be excited about what's next to come. But hey, we have to deal with a lot of challenges as well. Let's take a look to these challenges. First one, first group, high economic costs, business model adaptation, and also unclear economic benefits, excessive investment. Sometimes we go through the wrong road and we got to go back. That's really expensive. Then organizational challenges. We're talking about IT security issues. We're greatly aggravated by the inherent need to open up those previously closed production shops. Uh, then also reliability and stability needed for critical machine-to-machine communications. We have a lot in the game. In the future, the machines will be talking one to each other. And I'm not talking really about Terminator, the movie, uh, but we can expect things like that. And imagine that a system uh, controlling electricity goes down. That can be terrible. And that can happen anytime. And then here we include the very short and stable latency times. This is vital as well. Also, they need to maintain the integrity of production processes, and they need to avoid any IT snacks, as those would cause expensive production outages. They need to protect industrial know-how, contained also in the control files for the industrial automation gear. Hackers will be a big danger in the near future, as they are now. Also, in terms of organizational issues, we can have the lack of adequate skill sets to expedite the transition towards a fourth industrial revolution, and then low top management commitment that is happening, and insufficient qualification of employees. We need to teach the employees with the new techniques and with the new elements of technology. Then social challenges. First one, privacy concerns. We all know about this. Our privacy is constantly in danger. Gotta be very careful about this, and we gotta be aware of these problems. Then second, surveillance and distrust. Trust is the basic, or is the fundamental and key um, feature of all of this. Then general reluctance to change by stakeholders. Then also threat of redundancy of the corporate IT department. And last of the social challenges, the loss of many jobs to automatic processes and IT control processes, especially for blue collar workers. This is a menace that we have to take care. And then the last challenges are political. First one, lack of regulation, standards and forms of certifications. And of course, unclear legal issues and data security. Fortunately, the European community is very aware of this and is very active in terms of legal production. Even the European Commission sees an enormous economic benefit in a digital single market. Hence, the Commission has issued a digital single market strategy for Europe to push the most essential aspects, such as cloud computing, big data, and platforms. These are three of the papers that have been produced by the European community. Seizing the chances of digitalization outlined by the European Commission could resolve existing obstacles for innovation in the sector of legal metrology. The new approach of the European Commission sets up a quality infrastructure where measuring instruments and related legal processes are embedded. A quality infrastructure is generally understood to be the totality of the institutional framework required to establish and implement standardizations, methodology, accreditation, and conformity assessment services necessary to provide evidence that products and services meet defined requirements, be it demanded by authorities or the marketplace. Some of the colleagues today have talked about this. It is estimated that there are 50 million measuring instruments in the EU market, which are governed by European directives of this new approach. In most industrialized countries, legally relevant measurements are responsible for a share of 4% to 6% of the European gross domestic product, equivalent to 660, 990 billion euros per year. And the European leadership on this matter has been taken long ago by our good German friends from the German Metrology Institute, PTB, as you had the chance to see in Mr. Wiedenhoefer presentation a few minutes ago. But let me go a little further and let's take a look about what the PTB is saying about this particular matter. They're basically pointing us the the where to go, where we are going. The prerequisite, and basically what we're talking is about the need of trust. We need trustable systems. We need trustable markets. We need trustable technologies. And the prerequisite, according to the PTB, the prerequisite for the acceptance and sustainable implementation of all the evolved innovative technologies that I've been talking about is sufficient trust in their security and reliability. We need to trust this. This is a challenging task and requires extensive research and development in measurement technology, data science, and information security. In particular, Metrology institutes as the foundation of trust in measurement results and confidence in measurement-based decision-making are requested to address these issues. The PTB is taking up the challenges of digitalization and will advance a sustainable digital transformation of metrology to establish it as a source of innovation in the digitalization of industry and society. PTB's development areas in digitalization contain, but are by far not limited to, reference architectures for legal metrology, a digital calibration certificate, and so on. Most of these have been presented by uh, Mr. Mr. Thomas, Wiedenhoefer. In other words, innovation and confidence in an efficient quality infrastructure are the basis of a stable and successful economy and society. The main pillar of an efficient quality infrastructure is the ability to obtain valid data based on high precision measurements, which is the definition of metrology, by the way. I'm going to talk about the need of I'm talking about the need of a cloud infrastructure. And in these terms, the PTB have gone far and wide in this topic. And I wouldn't dare to improve the resulting jobs as I would never dare to improve a BMW. Germans know how to do this. Germans know about industry, how to do things. PTV have published a few good papers in digital transformation that are public and are the foundation for all the things that have to be done by metrology institutes, local metrology institutes. David, do I need to stop?
Yeah, I think you already talked for about 23, 24 minutes. So I think you have a couple more minutes and then you finish.
Okay, so I'm going to be quick. New identified focuses, the digital transformation of metrology service, metrology in the analysis of large quantity of data, metrology of the communication systems for digitalization, metrology for simulations and virtual measuring instruments. That's the focus of PTV in the digital transformation of metrology. The implementation strategy will be a metrology cloud. We need a metrology cloud, a digital calibration certificate, and virtual experiments and mathematics aided technology. But I'm talking about this, about the metrology cloud. Let me just be very quick. I'm coming to my end. This is the metrology cloud. Measure a lot of measure instruments. Can be a watch, can be a water, a water uh, watch, anything. And we have databases, infrastructures, smart data, and smart devices. And here are the stakeholders: users, sellers, customers, repairers as well. And we need a market surveillance. This market surveillance will be done by the metrology institutes of every country. And then in this slide, you can see we're going to see the objectives of this cloud infrastructure. These are four. The first one is we need a trustworthy metrology core platform. These are basically the scheme. In this trustworthy core platform, we have the metrological administration. This will be the CEM, Centro Español de Metrología will be here because it has to be trustable, and it has to be secure. Then we need a test case repository where tests will be done. The digital twin, this is a very interesting topic. I will be talking in the fourth slide. I'm going to be quick. These are shared databases and smart services. Then we have auxiliary databases, uh, market surveillance as well. Market surveillance, for instance, water, electricity, gas, but a lot of things are coming in this field. The manufacturers will be here too, users of course, and once again measuring instruments. Going to the second objective, the trustworthy metrology core platform. This is what I'm talking about. It's like Amazon Web Services or Azure or Alibaba Cloud. We need a system, a platform where we can deal with all of these problems. Software updates, monitoring of operational and legal processes, communication information, change and administrative processes, profile management, once again here, digital twins, information security management, key management, incident management, and certificate management. This is going to be key for the metrological administration in the next future. See another objective, references architectures, smart services. These are the apps, the famous apps we all have in our telephones. And then this is very interesting, the smart data as a service. This is called as well knowledge as a services. It's going to be a key field in the near future. Sorry, David, I went too far. I'm sorry about this. Third objective, technology-driven metrological support services. Here we're talking about digital twins. This is going to be really exciting. And last one, data-driven metrological support services. This is the work of the PTB, very interesting. I really advise you to go to the PTB and keep on studying this. Thanks a lot. I'm so sorry for taking so long.
Okay. Thank you very much, Carlos. Don't worry, I know we don't have much time today. There are too many speakers, so it's complicated if we stay longer. Okay, thank you very much for your presentation, Carlos.